Now we're all celebrating the fact that England have done so well in the Ashes and that they've been retained in the UK. And so to find out how the bowlers can make the balls so unpredictable for the batsmen, I've come to visit Dr. Hugh Hunt, an Australian, I have to say, expert on spinning things. Hugh, I guess not such great news for you.
Well, it's pretty good news for cricket. I think that after 18 years of Australian dominance, it's okay for England to have a few years of its own.
So how does spin work? How does it make these balls so unpredictable?
Well, spin does three things, basically. Through the air, the spinning ball interacts with the air in just the same way as an aircraft interacts with the air. When the spinning ball then bounces on the ground, the spinning ball interacts with the ground. That's the second thing. And the third thing is that fast bowlers can use spin to stabilise the ball through the air, and it's the gyroscopic effect.
Now, you've got some balls here in front of us. Are you going to demonstrate how this spin works?
Well, the first thing I've got is just an ordinary bouncy rubber super ball. I can put backspin on the ball, and the ball will
bounces back to
bounces back to me, exactly right. And I can put side spin on it, and the ball will shoot off to one side. Now, those kinds of spin effects we're seeing there are the effects of the spin when the ball hits the ground. Now, the classic Shane Warne leg spin is about the ball spinning so much that when it hits the ground, that Mike Gatting delivery, you might remember, the ball came right around Mike Gatting's legs, but that was because it gripped into the turf and spun just like the Super Ball does.
So this is the interaction of the ball with the surface it's colliding with, but there's also the effect aerodynamically of how the ball's flying through the air.
Footballs are very good for demonstrating this. I've actually got a very lightweight indoor football which I can just blow up. Right, blown up my football. And with this ball I can put some backspin on, and I just shot that across the room then, and the ball really hovered at the same level. In fact, it sort of lifted up. Incidentally, that's the same spin that Barnes Wallis used in his bouncing bomb for dambusters to try and prevent the bombs from hitting the surface of the water and breaking up. But that's an aside.
So that's meaning that the ball can travel much further than a batsman might expect it to.
The ball will then be in the air for longer and be more affected by cross breezes, all sorts of things that backspin can do. And then topspin makes the ball descend to the ground much more quickly. The ball will sink.
Okay, so that's dived straight down to the ground there.
Yeah, so topspin makes the ball dive. I can put some side spin on, and you can see that it curves around.
And that flew off to the left.
I can put side spin on the other way, and it curves off to
and
the
that
right.
flies off to the right. So what is the aerodynamic force acting on that football that's making it swerve like that?
Well, there's an effect called the Magnus effect. And the idea is that if you imagine air blowing over a stationary ball, it will blow nice and symmetrically. As much air will go over the top of the ball as goes underneath the ball. But if I now start spinning the ball, then air is going to be dragged around in one direction, preferentially to the other. And that means that there's going to be more curvature of the streamlines on one side than on the other. And just like on a wing, it's the curvature of the streamlines that causes lift, then the curvature of the streamlines on a ball causes lift.
So just as the wings of a plane push it up, you've got those streamlines curving around that ball, and that's pushing it off to one side.
That's absolutely right. And in fact, there's a whole way of looking at how wings work, which is called circulation theory, which essentially says, can we think of the vortex that a wing creates and use that vortex to determine how much lift is created? In other words, a wing is a clever way of producing the Magnus effect without needing to spin a ball.
Now, you've been imparting this spin by punching the football in different places. How do bowlers put spin onto a cricket ball?
When you release the ball, you can release it by running the ball through your fingers, which is then called finger spin, or you can release the ball by rolling your whole wrist around as you might a frisbee.
And are those two different kinds of bowlers, or do bowlers use a combination of the two?
There are different types of bowlers. So you've got the finger spinners tend to be the leg spinners. the off spinners, wrist spinners, but different spin bowlers have different techniques which they develop, and they try to disguise what they're doing. You may have heard of a googly, where the ball comes out of the back of the hand in a way where the batsman thinks the ball is going to be spinning in one direction, but in fact it spins in the opposite direction, or it doesn't spin at all. You can imagine then that the batsman not quite knowing which direction the spin is going to be is a bit indecisive as to where to put the bat. And it's really about producing deliveries. You want to hit the bat, but you want to hit the edge of the bat so that the ball flies off to a nearby fieldsman who's going to grasp it in their greedy hands.
So what about the fast bowlers? Do they use spin as well?
Well, the fast bowlers want to take advantage of the seam on the ball. If they can get the ball to land with the seam near the point of contact, well, it's quite a big protuberance on the ball, and that might cause the ball to go off to the left or the right. But they've got to make sure that the seam stays upright. And if they spin the ball, then gyroscopically that stabilises the ball to make sure that the seam stays where you want it to go. There are other effects that fast bowlers use, and they might roughen up one side, or they might smoothen one side. You've seen the bowlers rub the ball on their trousers to keep one side shiny, and that enables the ball to swing, because one side being rough has got a different drag and different aerodynamic effect than the other side being smooth. And again, you want to spin the ball so that the ball is stabilised through the air by the gyroscopic effect. The other thing the seam does is the seam acts to provide some roughness to disturb the airflow, which means that it's a bit like having an angle of attack on a wing. If I can have the ball just slightly at an angle going through the air, then that helps to create lift in one direction or the other. And if I want to maintain that angle, then I need the spin to stabilise it.